Today we are going to discuss about the classical ciphers. So in the plain text we have view of sequence of elements where in the form of a bits or in the form of a characters. So in the classical ciphers you have two types. One is a substitution cipher, another one is the transposition cipher. Then coming to the what is meant by the substitution ciphers. The substitution ciphers are those which are replaced the one symbol with an other. So there are several substitution ciphers: Caesar cipher, monoalphabet cipher, Playfair, polyalphabetic cipher, and one-time pad. So coming to the Caesar cipher is earliest known substitution cipher and it is invented by the Julius Caesar. So each letter is replaced by the letter of three position further down the alphabet. So coming to the example of Caesar cipher, if you take an example of like Andhra Pradesh, then the letters have been replaced. So in our English alphabet, we have 26 letters. All those are replaced with 0 to 25. And we are going to shift all the letters to next three characters. So A is replaced by D, B is replaced by E, C is replaced by F. Like that, we are going to shift the positions till Z becomes the C. Now, if you take A, B, C, D till Z, this becomes the plain text and D, E, F, so on will whatever the shifted values are there becomes the ciphertext value. So, if you take the value like A, so if at all I have the plain text as A, B, my ciphertext value becomes the D, E value. So here it can be also say as a mathematical mapping of letters to a particular number. So we can have a plain text formula over here. So we are going to replace A value with 0 till the Z with 25. Then we have general Caesar cipher values as when you want to change the plain text to the ciphertext. So we are going to apply pl plus k mod 26. That means plain text value plus the key value mod 26. Suppose if I take an example like plain text value, suppose A is equal to 0. So 0 plus our key value is how much? 3. So we are shifting to 3 values. So 0 plus 3 mod 26, that becomes the value is equal to 3 only. So the value equal to 3, which is nothing but D becomes the value. So A is replaced with D. Similarly, we can get a plain text by taking this formula like C minus K mod 26. So this is the generalized manner of representing the Caesar cipher. Then coming to the crypt analysis of a Caesar cipher, so the key space is equal to 26. So it is vulnerable to the brute force attack. So brute force attack is an attack where the attacker finds the all possible ways of key to crack the plain text. So coming to the next monoalphabetic substitution cipher. So the monoalphabetic substitution cipher is a cipher where we are going to shuffle the letters and map each plain text letter to a different random ciphertext letter. So we are going to take the plain text values, then we are going to rearrange them randomly. So this becomes my plain text value. Randomly we have arranged some values. This becomes my ciphertext values. So similarly, the second example, if we wish to replace letters, so we can replace randomly in the monoalphabetic substitution. So it is very secure for the brute force attack since the number of possible ways to break down is equal to 26 factorial, where it is a good amount of keys, that is 4 into 10 power 26. So we can say with so many keys it is very secure against the brute force attack, but it is not secure against the some cryptanalytic attacks because the problem is the language. So our English language, we have certain letters which are frequently used and which are not frequently used. So we are going to see what are the frequently used letters. So here we are frequently used or the commonly used letters are T, R, N, I, O, A, S, and the rarely used letters are Z, J, K, Q and X. So based upon the tables of a single, double, triple letters, we are going to find out, the attacker will find out what the plaintext may be. So let us see the frequencies of the letters. So for A, the frequency is equal to 8.167, still Z. So these are the frequencies that we are mostly used by the all of us. So the based upon the statistics of double and triple letters, so in the double letters we generally use TH, HE, AN, IN, ER, RE, ESON, and the triple letters are D and ENT, ION, TIO for NED. So like this. So the disadvantage is attacker may guesses by observing the relative frequency of letters in the given text. Coming to the next method, that is polyalphabetic substitution cipher. So the similar to the monoalphabetic substitution cipher, even the polyalphabetic substitution cipher will work, but here we use the key where we are going to take the key value similar, which is the length of the same length of the plain text. So we are going to take the sequence of monoalphabetic cipher as an encrypted letters. So how we are going to find, the key determines which sequence of ciphers to use. Each plaintext letters has multiple corresponding ciphertext letters. This makes the crypt analysis harder since the letter frequency distribution will be a flatter. So one of the polyalphabetic ciphers is Wegener cipher. So the simplest polyalphabetic substitution cipher. So it will take the consider all Caesar ciphers like A to Z. Then we apply a key called as security. Then how we are going to replace? We are going to replace first with the security. Then we are going to write all the letters till the Z values. So we are going to repeat from the CY. And the decryption is also simple, which is the reverse of it. So let us take an example of a Wegener cipher. So here we have taken the keyword as a deceptive. So deceptive, we are going to take the length of the plain text. Similar to the length of the plain text, we are going to write down our key. Then we are going to rearrange them. So based upon the rearrangement, so how we are going to rearrange, how you are going to get this one, nothing but we have values where DW. So this key values, so let us move to the next example, you can observe. So this particular table represents the Wegener cipher. So when you are taking the plain text as thank you here, then we are going to take the key as cover. Now how we are going to write the ciphertext? Then T, which should be replaced by C. So TC, the key becomes your column letters. The plaintext becomes your row letters. Now take the values of T and C. Now T and C. T and C becomes the ciphertext value as V. Now replace with V. Now again H and O. H and O. H and replace with O. Again you have got V here. So replace the ciphertext value with V. Now A and V. A and V. Again replace with V. Then N and E. N and E. N, E. N, E, which is replaced by R. So replaced by R. So like that we are going to write down all the ciphertext values in this manner. Then security of the Wegener ciphers. So there are multiple ciphertext letters corresponding to each plaintext letters. So it is the frequency of the letters that may occur will be not that easy to find out what is the frequency of letters. So in the monoalphabetic, you have seen that the frequency of letters will be same for all the letters. Suppose if V is replaced by I there, then in the all the letters V is replaced by I. But here it is not replaced by in such a manner. So to break down the Venn cipher, they need to guess the key length. So if the key length is n, the cipher consists of n Caesar ciphers, plain text letters as a position, then k, n plus k, 2n plus k, 3n plus k, etc. are encoded with the same ciphers. So the attack of each individual ciphers as before. So guessing the key length. So the plain text word are separated by the multiple of key length and are encoded in the same way. So in our example, we have taken the plain text as D, so on, then D. So THE is being encrypted with some ciphertext words. So this ciphertext repeated patterns are being guessed. So it is not compulsory that the values that are there. So in the ciphertext they have occurred like VTW. So VTW. It is not compulsory that it will occur in the all the text. It may occur or it may not be occurring. So coming to the next method, that is one-time pad. So one-time pad is a method where each message requires a new key of the same length of the message, and the key is to use to encrypt and decrypt a single message, and then it is discarded. For example, if you take as the plain text as how are you, then we are going to write down all the words by all the letters by its values. So H is replaced by 7, O is replaced by 14, W by 22, A with O, and so on till U. Then again we are going to randomly take the one-time pad uh, words, letters, where you are going to have 13, 2, 1, we are going to get only one time. So whatever the values that are being generated, it is only used for one time. So these values are being taken and we are going to form the ciphertext. So once you get the ciphertext values, how we are going to get the ciphertext values? That is 13 plus 7, that it becomes the 20. 14 plus 2 16, 22 plus 1 23, like that we are going to get the total values. Then using the values by mod 26, you are going to get the letters like U, Q, X and so on. This becomes your ciphertext. To decrypt that particular values, we are going to take the same OTP value from the sender and we are going to decrypt the plain text. Then coming to the Playfair cipher. So Playfair cipher is one approach to improve the security is to encrypt multiple letters at a time. So it is invented by the Charles Wheaton in 1854, but it is named after his friend Baron Playfair. So in this example, you can use the 5 by 5 matrix and fill the letters of the key with respect to the duplicates and fill the rest of the matrix with the other letters. For example, if I take the example as Playfair, now Playfair, once you have written, you are not going to repeat the words till the Z. So since we have written Playfair, A is being repeated, then we go for the B. Then C, D, E, F and so on till Z words we are going to write. Once you have written, then we are going to take the message as hi. Suppose this hi, that is every plain text will be divided into only two letters. So HI is again replaced. So we are going to take the rectangular box. Then HI, since it is rectangular, HI, if it is there, then we are going to replace with the BM, that is corners. So here they have given, if it is a rectangle, pick the same rows and the opposite corners. See, similarly, you can take an example here. So for Playfair cipher, we have taken the plain text as crypto is too easy. Then the key is infosec. So find out the ciphertext. So we are going to replace the infosec as infosec. Then we are going to replace the ABCD values till Z. So since we are having 5 by 5 matrix, so we can accumulate only 25 letters. So one letter will be repeated over here. One letter will be repeated. So we are going to take as CR, that is C and R. C and R. So this is the block. So C and R, this becomes the block. Now we are going to take the opposite corner, so it becomes the AQ. Okay. Now similarly YP. So Y and P over here. So we are going to take this particular box. So Y and P. So this Y and P are the corners. So what we have to take? We have to take T and V. So T and V. So similarly T and O. So T and O. T and O. So T and O is a columnar. Is a column value. So when you are taking T and O, it is replaced with Y and B. So Y and B. So it is replaced with Y and B. So similarly I and S. I and S. Then we are going to replace with I and N. So like this we are going to replace all the values that are there in the plain text. That becomes our ciphertext. For the rectangular wise, we are going to replace all the column values. If you are getting in a single manner, if it is the value over this one, that is the corner value and the next value, then we are going to take the next value and this one. If it is the values in the form of a rectangular, only one row, then we are going to take the values as side by side. If it is coming side by side, like if you get FA, then you are going to replace with AK. So like that, you are going to replace all the values and you are going to get the ciphertext values. Then security of place phase cipher is equivalent to the monoalphabetic cipher with an alphabet of 26 into 26, which is nothing but 676 characters. Now security is much improved over the simple monoalphabetic cipher and was widely used for the many decades. For example, US and British military was using in the World War I and early of World War II. So once it is thought to be unbreakable, actually it can be broken, but because it still leaves some structure of plain text intact. So coming to the next ciphers, that is transposition ciphers. So in the transposition cipher can also be called as the permutation ciphers. This can be simply move the letters around rather than replacing them with something else. So there are two types of transposition ciphers. One is the rail fence, another one is the columnar. Coming to the first one, rail fence. So similar to the rail fence, even we are going to arrange the plain text values in the manner of triangle. So if you take the values, example as the thy secret is the prisoner, if though let it go, though art is a prisoner. So here the words are written in a form of the rail fence. So T on the top, H down, Y on the top, S down, E on the top, C down. So like this we are going to write similar to the rail fence. Once you have finished, we are going to take all the top letters, then we are going to take all the down letters. And we are going to get as a ciphertext values. So you can have another example as hello world. So hello world you can get as the HOR, then ELOL, LWD. So like this we are going to get the hello world message. So coming to the next method, that is columnar transposition cipher. So the plain text is written row by row in a rectangle, and we are going to write down them in form of a columns in a specified value of key. So we are going to take the key value. Suppose the plain text value is attack postponed until 2 a.m. So how we are going to represent? So we are going to take the key value, then we are going to write all the plain text in the form of a matrix where attack postponed until the 2 a.m. Then the remaining letters are replaced with some other letters. Then we are going to take the ciphertext as the column 1, the value that is there 1. Then this value is taken as the ciphertext first value, then second value, third value, fourth value, fifth value, sixth and seventh. So you are going to get the ciphertext as TTANA, APTM and so on till the last. So like this columnar transposition cipher works. Thank you.